Hi, in this video, I'm going to go through LeetCode 141, which is linked list cycle. So this question asking us to determine if the linked list is a cycle. So for example, for this one, -4 should be the last node here, right? But then it's pointing to the second node here. So if there's a cycle here. If there's no the -4 is not pointing to 2 and it's pointing to null, it means that there's no cycle here. And looks pretty straightforward for the illustration. So now I have two approaches of doing this. The first one is the set approach, and the second one is using two pointers. We'll start with the set approach first. So at first, you have to create a scene. You call this scene. It's a set, and every time we'll add the nodes in this set. So for example, for the first one is a 3, right? So we add this to this scene set. The first one is 3, and then the second one 2, and it's not in the scene set, so we just add it to the set. 0, this one is also not in the set, and we add it, and also for -4. And the next node after -4 is 2, right? And we know that this node here is inside the set, so just return true. In the case where there's no cycle here, -4 points to the no pointer, right? So when it reaches the no pointer, we just return false. So let's try to do this on LeetCode. So at first, you have to create a scene set, and we'll look through the linked list. So head means that when the head is not null, we'll continue. If head is in scene, it means that there is a cycle here, right? Because for the previous example, 2 is in the set and -4 is pointing to 2. So it's in the set, we just return true. If it's not in the scene set, it means that it's a new node here. So we just add it to the set. And we'll move the pointer one node forward. When the while loop ends and there's no returning true here, we just return false because it means that it's reached the end, the no pointer here, and there's no cycle. So when you run this, it should be all accepted. And then for the second approach, for two pointers, you need a slow pointer and a fast pointer. The blue one will be the slow pointer, and then the red one will be the fast pointer. So in this case, we have to let the fast pointer move 2 steps, and that's why it's called fast. And for slow pointer, we just make it move 1 step forward. If there's a cycle inside the linked list, they will always meet with each other. And we'll let the fast pointer move first. So at first, the fast pointer will move 2 steps forward, right? And then the slow pointer will move 1 step. Then the fast pointer will move 2 steps. And here they already meet. And let's do another example where there's another 2 nodes here. And both the fast slow pointers have to start here. So the fast pointer will move 2 steps forward, and then the slow pointer will move 1 step, 2 steps, 1 step, 2 steps, 1 step. Here they meet. And the reason why they will always meet with each other is because, for example, we've seen some cases, right? So for example, for the first one, could be something like this. And when the slow pointer moves 1 step, the fast pointer will move 2 steps, which they will meet here. In the other case where they are separated by another node, so for example, like this, when the slow pointer moves 1 step forward and fast pointer moves 2 steps, here they go back to the previous case where we just talked about. So they will always meet each other. So let's try this on LeetCode. So at first, you can just check if head is none or head.next is none. Then just return false because it means that there's only one element in the linked list. So it's definitely no cycle. So just return false. Then we need to initialize two pointers, the fast and slow pointer, and we'll let them point to head at first. Then we'll loop through and fast on next. The reason why we need to include fast on next is because the fast pointer will move 2 steps forward, right? If fast.next is a null, then when you do fast.next, it will be an error here. So you have to check the fast and fast.next. Then we'll let the fast pointer move 2 steps forward. And the slow pointer will move 1 step forward. If they are equal to each other, it means they meet at some point, right? So it's return true because there's a cycle there. Then if this loops end here, it means that like for this case, maybe this cancels and it reaches like the no pointer here, it means there's no cycle, right? So you can just return false. In the case where there's a cycle, it can never, like this loop can never break. It can only return true here. So if it's like it breaks here and it's not returning true, it means that there's no cycle here. So you just return false. And when you submit it, now it's working. And thank you for watching this video.